calculator, iPad, flip down, bag. We're good. All right, so here's our setup. We're told that we have a polarized ray, or laser, excuse me, going in this way. It's this medium, it's this medium, and then hits a third medium. We also know that no reflection is happening, so this has to be Brewster's angle. And we know that no refraction is happening, so this has to be total internal reflection. So the question is, what is the range that N2 could possibly be? We're also given that this angle here is 32.2 degrees. This reflection index is 1.13. So let's get started. Let's kind of go step by step here. We're going to go from this medium that N1 holds to this medium. We're going to call this medium N3 just for the sake of consistency, right? So let's try to figure out what N3 beam is. So we can start with the equation N1 sine theta, we'll call that 1A. We'll see why in a second, is equal to N3 sine theta 3. Now, I call it 1A because if we look at the perpendicular, we're not actually working with that 33.2 degrees, right? So here's the perpendicular, we're actually working with this angle here. So what's that angle? Well, it's 90 degrees minus 33.2 degrees. And what's that? That's gonna be 56.8 degrees. Now we know sine theta 1A is whatever sine of 56.8 is, so we're gonna plug it in. N1 is 1.13 sine 56.8 degrees. And then we know that this is Brewster's angle because there's no reflection happening. So we can use that to kind of figure out, like, okay, well, if we know that, then this angle here that we want for sine theta we can find, which means we can isolate N3. So knowing that it's Brewster's angle, it would be sine of 90 minus this here, 56.8. So altogether, that's going to give us N3 is equal to 1.13 sine 56.8 over sine 90 minus 56.8. It's going to give us an N value of 1.7268. We're going to cut this down later just for now when we're still calculating. We're going to keep a few more sig figs. We're going to stop at 8 because the next one is a 2, so we round down. Now, let's record this on the side. We'll say found. N3 is equal to 1.7268. So we could manually go from N3 to the next medium up to N2, or we can apply the fact that if N3 sine theta 3 is equal to, we'll call this N4 sine theta 4, and N4 sine theta 4 is equal to N2 sine theta 2, then of course N2 sine theta 2 is equal to N3 sine theta 3. We just kind of jump over there. Let's have some fun. Let's switch to green. So let's try and figure that out. You know, N3 sine of theta 3 is equal to N2 sine theta 2. Well, let's think. If we know that it's total internal reflection, because we're given that there's no refraction happening, then that would have to mean theta 2 is 90 degrees. So we can kind of just start cutting, right? Because here, this is just sine of 90 degrees, and that's equal to 1. So this just becomes 1, and now what we're left with is just N3 sine theta 3 is equal to N2. So now we know what N3, and we know what theta 3 are, so we can use that to just isolate N2. Well, let's do that. So we get N2 is equal to N3, which is 1.7268 sine theta 3, which we know to be 90 minus, oh, it's 2. Alright, so now let's just do that and figure out what N2 is. 1.7268 sine 53.2. It's way too small. Oh, duh. It's because we're not. Oh, sorry. Backtrack. It's because we used the wrong. We used the wrong angle. We're not using 33.2. 33.2. If you'll recall, was the angle on this perpendicular, but going from here to here, we're actually using the perpendicular here. So if we know that it's 33.2 that way, then we're gonna have to do 90 minus 33.2 over here. Sorry, 90 minus 33.2 degrees. Yeah, I realized the error because what came out was 0.94, which is smaller than 1, which makes it invalid. So now we know that it's 56.8 once again. We can do 1.7268 sine 90 minus 33.2. There we go. Now, that makes more sense. Now we get a value that's greater than 1, so it's actually valid. What we get is 1.449. We'll put it there, 449. Yeah. No, excuse me, 4449. Alright, so we have a value, right? Yeah. So now consider this, right? If we want the ratio to work, where sine theta 3 is equal to n2 over n2 over n3. N2 cannot be greater than n3, so it's capped off there. But then n has to be greater than 1, which puts us at a range of, no, that makes sense. It puts us at a range of, the minimum would be 1, because n has to be greater than 1, less than, okay. Sorry, totally blank for a second. Yeah, because we're moving from a slower to faster medium, N3 has to be a lot bigger than N2. So N2 can't reach 1.7268, which means that 1.4449 is probably a good stopping point. Yeah, that would be the stopping point. So that means this is our max here, 1.4449. And then our minimum would have to be 1 because the n can't be greater than 1. So what we're left with is n between 1 as a minimum and 1.44 for our sig figs. But let's actually clean this up a bit more for the sig figs. What we get is 1.00 less than or equal to n2 less than or equal to 1.44 as our range of possible values for n2 that would make this situation happen here given this information.